This is part 4 of the fractions packet. Let's start with this page. Divide. State any excluded values, the wholes of the vertical asymptotes. Here's the steps for dividing fractions. Step 1, keep the first fraction. So let's look at this example right here. We have 1 over n minus 3 divided by n minus 9 all over n squared minus n minus 6. So we keep the first fraction. Step 2, change divide to multiply. Step 3, flip the second fraction. So you get the reciprocal of it. So it'll be n squared minus n minus 6 all over n minus 9. Okay, the next step is to factor. This top looks like it could be factored. So let's go ahead and factor that. It will be n plus 2 and n minus 3. From here, see if there's any wholes. This is stuff that cancels. N minus 3 and n minus 3 do cancel. So you do have a whole at n equals 3, because 3 minus 3 is 0. Multiply straight across, so we have 1 times n plus 2. That's just n plus 2. And 1 times n minus 9 is n minus 9. Double check for more wholes. There aren't any. And then let's find the vertical asymptote. You set the denominator equal to 0. Well, when n minus 9 equals 0, n is 9. So your excluded values are n cannot equal 3 and n cannot equal 9. Let's do one more. So step 1, you keep the fraction, first fraction. Step 2, change divide to multiply. Step 3, get the reciprocal of the second fraction. And then you factor. N squared minus 64 for both of these could be factored into n plus 8 and n minus 8. Which all of these cancel, so we have 2 wholes. We have wholes at n equals plus or minus 8. So those are your exclude values. 4 over 1 is just 4. So our simplified fraction is 4 with excluded values at n equals 8 and negative 8. Okay, let's look at the next page, multiply. State any excluded values, wholes and vertical asymptotes. Let's go over the steps. So let's look at this one. We have 5 over 9 times 20 over 6. Well, there's nothing we can factor here. So we're going to multiply straight across and simplify. Now, if you do want to factor the numbers into the prime factorization form, you can do that as well. We have 5 over 3 times 3 times 5 times 2 times 2 all over 3 times 2. Okay, the things that will cancel, the 2's, and that's it. So to multiply these, we have 5 times 5, that's 25. 25 times 2 is 50. And 3 times 3 times 3 is 27. There's no vertical asymptotes and there's no holes because there are no variables. Even though these 2's canceled out, there's no variables, so there would be no holes. Let's look at this one. So let's see what would cancel out here. Well, the n minus 2's would cancel, and the n plus 5's would cancel. So that means we have 2 holes. Holes at n equals 2 and negative 5. Because negative 5 plus 5 is 0, and 2 minus 2 is 0. So we're left with n minus 2 all over 10. There's no vertical asymptotes because there's no variables at the bottom in the denominator. So that's it. Let's go to the next page with proportions. For proportions, we're going to solve them by cross multiply using the butterfly method. So let's look at the first one. 3/4 equals x over 8. 3 times 8 is 24. 4 times x is 4x. So we have 24 equals 4 times something. To find out that something, we could divide each side of the relation by 4. 24 divided by 4 is 6. So x equals 6. For this particular question, you could have also seen that 4 times 2 equals 8. So 6 times 2 equals 6. Let's look at another one. Let's do the 2/7 equals x over 20. So first thing, we cross multiply. 2 times 20 is 40. 7 times x is 7x. To get x, we divide both sides by 7. So x equals 47ths. Let's look at another one. 2 over x equals x over 8. Cross multiply. 2 times 8 is 16. X times x is x squared. Get the square root of both sides. The square root of x squared is x, and the square root of 16 is 4. Now we could also have negative 4. So the answers are x equals plus or minus 4. X equals negative 1 on this one. Not positive 1 because that would be a vertical asymptote here. Let's look at one more example for the proportions. So let's cross multiply this last one. So we have 35 equals 3x minus 1, 2x plus 5. So this isn't the 0 equals form, so we're going to have to multiply these in using box or FOIL. And then when you put this into the calculator, you should get about negative 3.88 and 1.72. If you want to get an exact answer, you would put these into the quadratic formula. Okay, let's go to the next page. Finding least common multiples. To find the LCM in the calculator, you go to Calculate, Menu 2, 4. So for example, if you had 2 and 5, you would press those numbers, and they would have LCM and then parentheses 2, 5, and then enter. And if you put that in, you should get 10. Now this will only work for the numbers. It will say error if you try to put in the X, or if you try to put in more than 2 numbers at a time. So for this one, the LCM of 3 and 6 is 6. And then you choose which one has more X's, and you put that next to the number. So we have 6x is your least common multiple. X squared and x, the least common multiple would be x squared. You choose the x with the bigger exponent. Now when you get to the one that has 3 numbers, one thing that we could do is write the multiples of each of these numbers. So here's 5, and then we have 6, 12, 18, 24, 30, and then 10, 20, 30. So it looks like the least common multiple for these would be 30. So we write 30 here in the blank. Okay, try the rest of these on your own. And let's go to the bottom part. Set up the following addition, subtraction, fraction expressions. So from this one, we knew that our LCM was 10. So to get 10, we're going to multiply these by 5 and these by 2. Now you can always multiply this fraction by this denominator and this fraction by this denominator, even though it's not always the least common multiple. But if it's not the least common multiple, there will be some reducing needed at the end. So our setup fraction would be 5 plus 2 all over 10. Let's look at the this one right here. X plus 1 and x minus 1. You'll multiply these by x minus 1, and the other one's by x plus 1. And for these, let's always just leave the denominator factored out, so we don't need to box or FOIL this. So these denominators are the same now, so we can put them together. So x minus 1 plus x plus 1 all over x minus 1, x plus 1. Okay, try the rest of these. So here's the steps to set up with the LCM. Find the least common multiple of the denominators. Multiply the first fraction by that special 1. Whatever it is to multiply this to get the least common multiple. And multiply the second fraction by the other special 1. Let's look at the next page. Subtract. State any excluded values, wholes, and vertical asymptotes. So here's the steps for adding and subtracting fractions. Step 1, you set fractions up with the LCM. So the LCM of 10 and 8 would be 40. Well, to get 40, you multiply 10 by 4 and 8 by 5. So after you set up the fractions, you should get 4 over 40 minus 15 over 40. The next step, distribute the negative sign into each term. So negative 1 times 15 would be negative 15. So we have 4 over 40 plus negative 15 over 40. So we change this middle sign to a plus sign. The next step is to combine the numerators. In this example, there's nothing to factor, and there's no wholes and no vertical asymptotes because there are no variables. So our answer would be negative 11 over 40. Let's look at another one. So for these, we would need to multiply by p minus 3. And since this is 3 times p minus 3, we would only multiply these by 1, which would leave them the same. And so your answer would just be 4p squared minus 12p minus 2 all over 3p minus 3. And you would have one vertical asymptote at p equals 3. Let's look at one more example on this page. So the least common multiple of these would just be to multiply them by each other. So let's multiply these by 2 and these by 3v. So we have 9v all over 6v minus 2u plus 2v all over 6v. Okay, distribute the negative. We get 9v over 6v plus negative 2u minus 2v all over 6v. If we're to combine like terms, 9v minus 2v is 7v. So our answer would be negative 2u plus 7v all over 6v. And we have one vertical asymptote at v equals 0. So that's our excluded value. Add, state any excluded values, wholes or vertical asymptotes. So here's the steps for adding fractions. Write those down. Okay, so let's look at this example. We'll multiply each of these by 2x. And then we'll have 7 plus 2x all over 2x times x plus 3. There's nothing that cancels here, so there's no wholes. But we do have two vertical asymptotes. One at x equals 0, and one at x equals negative 3. Okay, let's go to the last page. Solving rational equations and inequalities. So each of these sides, this is the equal side, this is not equal, this was less than, this was less than or equal to, this was greater than, and then the last one is greater than or equal to. So when you divide each side of an inequality by a negative number, the inequality sign flips. Okay, let's solve an equation here. And you check for extraneous solutions at the end. So let's set this up first. Let's make all of these have 6n squared with it. So to get this one, we're going to multiply each one of these by 6. To get this one to be 6n squared, we're going to multiply each one by n. So to set up this equation, we have n over 6n squared minus 18 over 6n squared equals 1 over 6n squared. From here, we have n minus 18 all over 6n squared equals 1 over 6n squared. From here, we're going to cross multiply. So now we have 6n cubed minus 108 n squared. And then that equals 6n squared. Let's subtract the 6n squared from both sides. So we have 6n cubed minus 114 n squared equals 0. Let's factor and solve for n. So we could take out 6n squared, and we have n minus 19 equals 0. If you set each of these equal to 0, we get n equals 0 and 19. Now, for extraneous solutions, we'll look at the original equation to see if any of them is undefined here. Well, if we put 0 in for the denominator, that would be undefined, so that's extraneous. The 19 won't do that. So your final answer is n equals 19.